Hello student, welcome again to the journey of understanding theorem. I am here with a new theorem, inscribed angle theorem. To know this theorem very well, we should know about the arc of a circle. So let us start. Just see arc of a circle. First of all, we will see minor arc and major arc. What is minor arc and what is major arc? If we will draw a circle, in this circle, there is a center, let it be O. We will take any 2 points on the circle A and B. And this part which does not contain the center is called as minor arc of the circle. And this center part is called as major arc of the circle. Okay, so this is minor arc and major arc. Now, what is major? Circle itself a complete curve, and measure of this complete curve, a ring is a circle. So measure of this particular complete curve is 360, and therefore the measure of circle is 360. Now, what is half of the circle? It is called as semicircle. So measure of the semicircle is 180 degree. Now, how to get the measure of minor arc? This is a big question. So, for getting the measure of minor arc, I will explain you here. See, we should understand some particular term to get the answer for that. Let's see. I have taken 2 points on circle A and B. Now I have joined them with the radius, with the center of the circle. That is OA and OB are the radii of the circle. So we are getting an angle here. This angle is called as central angle. Why? Because it is on the center. So angle AOB is a central angle. It is a central angle. Now measure of this central angle is theta. Suppose the measure of this angle is theta. Then measure of this arc, minor arc, will become theta. Whatever is the measure of the central angle, that will be the measure of its corresponding minor arc. This is the definition of the measure of minor arc. To find the measure of minor arc, we should know the measure of corresponding central angle. Okay, and that will be the measure of minor arc. So this is the definition of measure of minor arc. Now question remains there, how to find the measure of major arc? So there is no specific formula. We know that this is minor arc and this part remains, this is the major arc of the circle. This is the major arc of the circle. We'll give it name AXB. Suppose AXB is the major arc. Then what happens? Measure of this arc AXB will be measure of circle. Circle has 360 measure. So we have to subtract the measure of the minor arc from 360, that is theta, and we will get the measure of major arc. Nothing more. Means to get the measure of major arc, you should know the measure of minor arc first. Now, how will get the measure of minor arc? By knowing the central angle, corresponding central angle. Okay. So, after that, here I have explained you in this diagram. See, this is central angle and here arc AXC is given. So, measure of arc AXC, that is minor arc, is equal to the central angle AOC. Now, congruent arcs. Which two arcs are called as congruent arcs? There are two factors. First, their measures should be same. Second, their radii should be same. So, congruent arcs means what? Congruent arcs means they must have same measure and equal radii. If they are having same measures and equal radii, the arcs are called as congruent arcs. Now, there are some theorems related to this congruent arc, and you have learned the statement of this particular arc in 9th standard only. We will see what are they. Now, if two arcs, suppose this is AB and this is CD, these two arcs, AB and CD. If these two arcs are congruent, then their corresponding chords, that is AB and CD, are also congruent to each other. This is a theorem. If arc AB is congruent to arc CD, then. And the proof of this theorem is very easy. Then we can say that chord AB is congruent to chord CD. Okay. Converse of this theorem is what? If the chords are congruent, then their corresponding minor arcs are also congruent. Okay. And now the definition of inscribed angle. What do you mean by inscribed angle? If two secants intersect each other on the circle, suppose we can extend it, these are the secants. Let this P, this point is A, this is PA and this is PB. Secant PA and secant PB are intersecting each other on the circle at point P. Their intersection point is common. So here we can get one angle, that is angle APB, and this angle is called as inscribed angle. What is this? This is inscribed angle. If two secants intersect each other on the circle, then the angle made by this is called as inscribed angle. One more definition is there. If we'll take any 2 points on the circle A and B and we'll join it with any other point on the circle, it makes an angle, and that angle is also called as inscribed angle. These are the simple definition of inscribed angle. Now what is intercepted arc? The arc which comes in the interior of the inscribed angle is called as intercepted arc. I'll write here AXB. Here you can say this arc AXB is an intercepted arc. It is an intercepted arc. And here we can say that angle PAPB is inscribed in the arc APB and its intercepted arc is AXB. Okay, so this is inscribed angle and intercepted arc. What is this inscribed angle? The measure of the inscribed angle is half the measure of its intercepted arc. This is the inscribed angle theorem that we are going to prove. Before proving the theorem, as we know, we came across some points which we are going to use in that. That is our previous knowledge. We have already learned it. Okay. The first is isosceles triangle theorem. In your 9th standard, it is one of the important theorem. What is isosceles triangle? If two sides of a triangle are congruent, then the triangle is called as isosceles triangle. What is isosceles triangle theorem? If two sides of a triangle are congruent, then angle opposite to them are also congruent. This is the isosceles triangle theorem or theorem of isosceles triangle, you can say. If two sides of a triangle are congruent, then angle opposite to them are also congruent. Remember this. Next point, exterior angle theorem. You can say remote interior angle theorem or exterior angle theorem. In a triangle, if exterior angle is given to you, in 9th standard, a detail about that is given in your book. This is a triangle ABC. We have extended side BC so that we will get the point D here, such that this points B dash, C dash, D means they are collinear and C comes somewhere between B and D. So here we get one angle ACD. Which angle? Angle ACD. It is an exterior angle for triangle ABC. For triangle ABC. Measure of this angle is sum of the measure of its remote interior angle. Remote means, see, there are three angles in a triangle. One is adjacent to the exterior angle. We should not take that into consideration. Remote means far away. The angles, interior angles of a triangle which are far away from this. So, which angles are angle A and angle B? So, angle ACD is equal to angle A plus angle B. This is our remote interior angle theorem or exterior angle theorem, whatever you say. So, measure of the exterior angle is always greater than its remote interior angle, and therefore it is equal to sum of this remote interior angle. Okay, so this is exterior angle theorem. In short, I have explained you. Now, third we should know the definition of measure of minor arc. I have told you that measure of the minor arc is nothing but the measure of its corresponding central angle. So this we are going to use these three things. So I hope all of you should remember this while proving this theorem. Otherwise, it will become difficult to understand a theorem. Previous knowledge is must. Now we will come across the inscribed angle theorem. Measure of inscribed angle is half the measure of its intercepted arc. This statement we are going to prove now. Okay, so again the compulsory part, the diagram is given to you. In this diagram, center of the circle is O. So in a circle with center O, angle BAC is inscribed in the arc BAC. Angle BAC is inscribed in the arc BAC. And arc BDC is its intercepted arc. This is given part. What we need to prove? Measure of the angle BAC, this angle, is half of the measure of intercepted arc, that is arc BDC. This we are going to prove. And for doing this, we have to do some construction. We have to draw AO such that it will intersect the circle at point E. So I have written in the construction, and join OC. After joining this OA and OC, we get a small triangle AOC. Okay, now in this triangle AOC, side OA and OC, these two sides, radii of the same circle. That means in triangle AOC, two sides are congruent. If two sides are congruent, triangle is an isosceles triangle. So angle opposite to the congruent sides are congruent. So this angle OAC is congruent to angle OCA, isosceles triangle theorem. Let the measure of each of them is x degree. Let the measure of each of them is x degree. So we have taken the measure of each of them is x degree. Okay. Now, for this triangle, this angle EOC is an exterior angle. Angle EOC is an exterior angle. What is the measure of exterior angle? It is the sum of the measure of its remote interior angle. So it will be x plus x. That means it is 2x. So I have written here EOC is OAC plus OCA, and that is x plus x, that is 2x degree. This is EOC is the central angle. Measure of the central angle is equal to the measure of its corresponding minor arc. So measure of arc EC is equal to 2x degree. Similarly, we can show that measure of arc BE is also 2x degree. Okay, by proceeding in the same manner, by drawing OB, we can get this result, but we need not write the proof for that because we have written for this. Second, you can write similarly, we can show that. After showing this, now this is the triangle. We know that measure of angle OAC is x and measure of arc EC is 2x. That means measure of angle OAC is half of the arc AC. So from statement 1 and 2, we got measure of angle OAC is half of the measure of arc EC. Okay, अब EAC, what is this OAC? This angle EAC. Why? Because we know that these points are E, O, E dash, O dash, A, they are collinear. So we can just, the angles are same, and this is the reason there, and same angle with different name. By proceeding in the same manner, we can get EAC is equal to half of arc BE. Okay. Now adding these two statements, EAC plus EAB. By adding these two, we will get half of arc AC. When I have taken half common, so this is EC plus arc AC plus arc BE. Now what is this? Arc EC plus arc BE. Which arc does it make? It makes complete arc BEC. And we can write the name of this as BDC. So angle BAC, and this is EAC plus EBC. This is angle EAC. This is angle EBC. What does it make? It makes angle BAC. So angle BAC is half of arc BEC. That means angle BAC is half of the measure of arc BDC. BAC is an inscribed angle and arc BDC is an intercepted arc. So measure of the inscribed angle is half the measure of its intercepted arc. In this way, we can prove only three things are given to us. Using this, we can easily prove this theorem. Yes, now student, some important corollaries are there which are related to this inscribed angle theorem. The first one is angle inscribed in the same arc are congruent. That means angle are inscribed in the same arc, they are congruent to each other. Here you can see this angle APB and angle AQB, they are having common endpoints. Only their vertices are different. So angle APB and angle AQB, these two angles are congruent to each other. Okay. Why? Because both of them are having measure half of this arc AXB. They are inscribed angle, their measure is half of the measure of its intercepted arc, and their intercepted arc is arc AXB. So measure of these two angles is equal, therefore they are congruent. So angle inscribed in the same arc are congruent. Proof of this theorem is very easy. You can try it yourself as I have written there. This you have to use inscribed angle theorem twice for the angle APB once and for the angle AQB second time. You will just equate the equation, you will get the answer. It's very simple. Second corollary, angle inscribed in the semicircle is a right angle. Again, we know the measure of semicircle is 180. So this angle APB is an inscribed angle. Measure of this semicircle AB is 180. So measure of the inscribed angle is half of the measure of its intercepted arc. Intercepted arc is semicircle. Its measure is 180. So half of 180 is 90. So angle inscribed in semicircle is always a right angle. Okay. This is second corollary. Now few important things I want to tell you. Actually, you have seen this inscribed angle here. The vertex of the angle lies on the circle itself. But if two segments intersect each other, their vertex may lie in the interior, their vertex may lie in the exterior. If their vertex lie in the interior of the circle, what will be the measure of this angle? Measure of this angle is half of the sum of these two intercepted arcs. That is angle ABQ is half of the measure of arc AQ plus arc PC. And if two segments intersect each other, their vertex lie in the exterior, then what happens? Then again we will get two intercepted arcs. Okay, so measure of this angle BPD will half of the measure of arc BD minus measure of arc AC. Here one, see, BD is the largest arc, this is the smaller one. Naturally, if you are subtracting, you have to subtract the smaller from the greater. So angle BPD will be half of arc BD minus arc AC. And this completes our inscribed angle theorem. I hope you have understood it well. What is inscribed angle theorem? Measure of the inscribed angle is half the measure of its intercepted arc. Their corollaries, angle inscribed in the same arc are congruent. Angle inscribed in a semicircle is a right angle. So you have to remember this thing, learn by heart, try it yourself, practice it, and you will be perfect in it. Okay, dear students, stay home, stay safe, goodbye.